Taking really cool pictures of tower guys on towers, and that's why I got into drones. Now, obviously, there's interest beyond just taking beautiful pictures, but the impact that I've been able to make with my drone on the tower industry is maybe a little bit of a different angle right now. And this is a nice example.
You meant to do that. Hey, your beard got shorter.
Hold on a second. I'm supposed to turn it. That's, you know, that brings up an interesting point about drones. If you've ever been attacked by that herd of angry bees coming up behind you, you know what that's like. So let's try this again. Okay, let's try this. Oh, there we go, okay. Drone pilot, technological idiot. Anyway, this is a beautiful shot of a tower guy. And my drone pilot, who's my son, who's better than I am, I can fly him too, but he got this amazing footage of a man climbing a tower and is performing this with a simple drone. If you're familiar with drones, it's a Phantom 2 with a GoPro camera. But being the pilot that he is, he's able to make this orbiting, rising shot, keeping on the center of focus while this climber's climbing. I love that little piece of video. We shot that. We had the opportunity to shoot that for the Discovery Channel, who did a story on this. Also, many of you have probably seen the changing the light bulb video on YouTube, which now has upwards of, maybe during this show, I think we're going to maybe hit 6 million views on the internet with this video. And it became, surprisingly to us, wildly popular and caused us to get all sorts of media requests. We were interviewed, CNN Money interviewed us, all kinds of crazy stuff. And here you can see that we submitted to the New York City Drone Film Festival, and we're an official selection at this film festival, which happens on March 5th. So we've gotten the tower guy and tower work, actually, out there into the public eye, and in a positive note. We've got nothing but positive response from this, and it's just garnered a lot of buzz, in my world anyway, about tower guys and what they do in a positive light. So it's been really cool. And here's a little piece that's kind of funny about this this particular video.
Hello there, my name's Jess. I'm calling for the Main Line Video Desk in the UK. We're writing a story about your extraordinary climb up the KDL-TV tower in Sioux.
I'm Kevin Schmidt, and I'm the International Tower Superstar.
For Sirius XM Radio, I'm Bill Bradley, and this is American Voices, a man who climbs towers.
Once you get up 300, 400, 500 feet, then you look out there and you can just see the prairies of South Dakota. You can see the mountains down in Colorado when you're out that direction. I mean, you've got an amazing view once you get up there.
What do you do when you have to change a light bulb that's 1,500 feet off the ground? You call my next guest, Kevin Schmidt. There's a YouTube video of him making one of his climbs that you've got to see.
Well, so far I've been on TV Technology, CNN Money, Mail Online, NBC Nightly News, New York Daily News, Popular Mechanics, Russia Today, Kim Commando, Discovery Channel, Wireless Estimator, American Voices with Senator Bill Bradley, KDLT News, the front page of the Sunday Argus Leader, Live Leak, and about every other video site on the internet, and 3 Japanese TV shows.
アメリカ・サウスダコタの大平原にそびえる電波塔。高さはなんと 457.2 メートル。ケビンさんはそのてっぺんで仕事をしている。ケビンさんはそのてっぺんで命綱を頼りに航空障害灯の電球を交換している。夜間飛行する航空機に存在を知らせるための電球で 日本では60メートルを超える建造物に設置が原則義務付けられている。しかし 457.2 メートル、登るのも一苦労。エレベーターはないのでただひたすらはしごを上がっている。てっぺんまで2時間もかかるという。命綱は2本、それを手の届く範囲で交互に引っ掛けながら地道に登る。ちなみに電波塔の設置とメンテナンスをしているケビンさんの会社、初任給は年収590万円だという。思わず足がすくむこの映像もケビンさんは
最高だよこの景色。
この仕事が転職だそうです。
電波塔の高いところで電球交換って言ってたけど、東京のスカイツリーとかもピカピカ光ってるじゃないですか、あれも交換してる人がいるってことですか？
でもスカイツリーやったらエレベーターでほぼ上まで行けるじゃないですか。これほんでなんか
そうだ、
この建物自体信用ならんというか揺れますよね。
Yeah, that's pretty funny. So, Kevin is the international tower superstar all over the world. Anyway, that was a lot of fun. That was fun to do that. And I've also got a couple of little pieces here I'll show you that you probably won't be able to see again because I started out, like I say, as a hobbyist here, not fully cognizant of all the rules and regulations that go on, although I'm not a complete idiot, and I had a pilot that I work with who I consulted every time I thought of doing one of these things, who would tell me where the airplanes can fly and where they can't. So I would stay out, and I found out that way that there's basically a cone around a tower that's a no-fly zone for those guys, so I figured, hey, that's the drone zone. And I put it to the test with this video, and I was contacted by the FAA, and they informed me that that's not really the case. Although it's true that you can't fly, that they can't fly there, that doesn't mean I can fly in there at this time. But in the end of that conversation, I asked the man from the FAA, so, did you like the video? And he said, yeah, it was pretty cool. So, I don't feel so bad about it. They liked it. But anyway, I was, here's a nice, kind of exciting little piece where I went down to Oklahoma City when Kevin Barber and Tower King 2 were taking down that Channel 9 tower. And as I was up there shooting them, a cloud bank blew in on me, and I was flying on instruments, which is also against the rules, but it kind of caught me off guard. I was fine, but it caught this beautiful footage of the tower and the guys using their gin pole up there in this cloud bank. This might be an exclusive now that we know this is against the rules. You can see the men there clinging to the side. No dramatic music here, but I should have some. Nice if you're doing a training thing about gin poles, that would be a beautiful shot for that. Pretty spectacular, and again, this is with my Phantom 2, although modified, and a GoPro camera, also modified. Another nice shot I took was this, which is just kind of a cool shot. And I think I'm probably below 400, so this might be legal. Anyway, it goes to my passion, as I say, of taking these beautiful shots of this awesome job, which you can't get. You know, in the wireless estimator, I know Craig Lacutis talked about how there are many, many videos out there that tower guys have taken, but usually of small interest generally. But this one that I put up there, 6 million hits, why is that? And I think that part of, the main reason is context. And I'll talk about that a little bit at the end. But let me go on to a little bit of Drone 101 for those of you who maybe not fully knowing what a drone is. This is the FAA terminology for it. S standing for small, UAV, unmanned aerial vehicle. UAS is the whole system, unmanned aerial system, or airplane, or aircraft system. The small UAV has to be less than 55 pounds and travel less than 100 miles an hour, essentially, basically. Now, do you think that this is that the quadricopter and these multi-rotor helicopters are a modern invention? Guess again. Check it out. The quadricopter. The first quadricopter was actually tested and tried, maybe, I don't know if it was successful or not, only 5 years after Kitty Hawk, 1908. This picture is from 1928. So the principle, the idea of a multi-rotor craft is not new. And here's one from the 50s, an actual manned quadricopter. And I can't imagine what it took to distribute the power and whatnot out to those engines, but pretty funky. Today, though, what's caused the rise of the drones today as we know it is many things, like the computer's ability to control the power distribution out to the motors, the small, powerful batteries and motors that have been developed, accelerometers, gyroscopes, the compass, all of these little miniaturized electronic things that can be put on this thing. The ability for these things to navigate using a GPS system. If you lose control of your drone, it'll fly back to you because of the GPS system. And things that are under development, and you don't necessarily find on every drone, but is being developed out there, is autonomous flight and obstacle avoidance, so they can run into stuff on their own. Then, to top that off, you have the camera gimbal, which to me is the key thing. You know, this device slung underneath the camera stays pointed at whatever you point it at, no matter how close the drone gets. That's a powerful little tool and really technological. And then first-person video, where you can actually see what the camera's seeing while you fly it. And that, altogether, is how we say has given rise to the drone, or the modern, what we're concerned with is this multi-rotor small UAV. And this is what's next.
I think we can make it, right? It's okay, Jim. Just stay calm and move as quietly as possible. Everyone understand? No sudden movements.
Google search, Bodega Beaches.
It's an Audi commercial, if you can figure that out. Yeah, there's some people who'd like to see that happen in every aspect, but will it come to that? I hope not. Okay. Now to a little bit of the work. I'll start to get into what the hope is maybe out there for the future of drones. In our work area, check this out. Here's some guys who put a drone together and they lift. I left this one on purpose for the buzz. This is 50 pounds of water. It's kind of amazing. That's like an LED beacon or, I don't know. I'm just making stuff up, but lifting 50 pounds, that's kind of interesting, kind of incredible. Me though, personally, I have been called on a couple of interesting jobs where the drone really fit into its perfect role. And in this case, we had a customer of ours, a broadcast customer, who was having reflected power on his TV antenna and didn't know what was going on. A little while later, he called out and had sent a photograph of the TV antenna laying in the field. So the entire top-mounted TV antenna cracked off and fell into the field, and they were concerned about the structural integrity up at the top. So it was the perfect drone job. They called me out. We flew up there to check out and to see what we could see. And this is some of the initial footage as we climbed up to the top of the tower. By the way, it takes this drone a minute and a half to go 1,500 feet up. So that gives me approximately 8 minutes to fly around at the top, and then the rest of that battery time to get to the ground. And what you see there is the inner conductor, the transmission line that was inside of the stick, hanging over the side, and where the antenna used to be. I don't know if you were watching carefully as you went up, though, that you would notice that there was no structural damage that you could see. And we took closer looks than this, too, but we looked at the guys up there. The antenna actually fell straight between a set of guys and touched nothing, not even a barbed wire fence. Maybe a gopher or something, but that's about it. And now with this, having gone up there to be able to check out the structural integrity of what had gone on up there, we saw that the antenna touched nothing. You know, if you've ever knocked a tower over, you know what happens. It jumps off the base a few feet. And I think this antenna probably did the same thing. As it leaned over and fell, it jumped and just took a clear and maybe a spin or two before it hit the ground flat. Also, what was of maybe most interest of all was that the guys, the tower crew that was there to go up, to button up this site and to see, you know, to take care of the problem as much as they could, were able to look at this video and these stills and decide what they needed, what was going to go on up there, and were able to avoid one complete reconnaissance climb up this 1,500-foot tower. So they were equipped to take care of the job. They knew what they were going to face before they ever went up, which was invaluable at that moment. And plus the peace of mind knowing that the structure was okay and going up there. So that really felt good. That was a real interesting, actual, real life tower job with a drone that really made sense and that worked well. We had another interesting occurrence where, in this case, the turnbuckle and shackle nearest to us without frost on it, that guy at the bottom, a turnbuckle sheared off, probably because of vibration, or at least that was the theory at the moment, but it was like a 1-inch turnbuckle, just sheared right off on the threaded part. So they wanted to go up and make sure everything was kosher at the top, so we went up and had a look at the shackle and to make sure that it was straight for being pulled back out, to see if it was stuck on anything. This was a nice experiment. A lot of the things I've done are like pushing the operational limits, I guess. It was 4 below 0 when I filmed this and flew the drone. And the drone operated like a champ up there. We had the RF turned off in both of these cases, but the temperature didn't seem to be a problem. And as we went down and were looking for stuff, I'll let it go down here. We were kind of checking to see if that guy was caught on anything so they could pull it back out. Fortunately, it was a bridle guide tower, otherwise it probably would have been in a pile on the ground, but it survived the initial let loose of that guy. This little guy, the guy hanging there on the right is the loose guy. But as you come down to the next guy level, you'll notice the guy doing the vibration. So we caught it on camera, that guy. You probably caught it from the ground before, but it was interesting catching it from the tower side. Where if any of you guys have worked on big iron, you've seen that happen, where you'll go up in the middle of a calm night and there's one guy vibrating like that. It's kind of a bizarre phenomenon. But anyway, we caught one here doing that, coming up soon. It's a beautiful landscape, though, isn't it? I would try to fast forward, but I'm afraid I'll mess it up. Okay, here you go. See the guy down in the foreground right there? Just that one guy sitting there humming away. And it wasn't a completely calm day. It was maybe a 10-mile-an-hour wind, but I don't know, maybe some of the engineers in the room can explain that phenomenon to us, but I've always wondered, how come that happens? Where did the energy come from that just keeps that guy moving all alone by itself? But anyway, it was fun to see that captured and to be able to go up and look things over for him. And the customers, of course, like all of us do, see that and just think, this is the greatest thing ever. They just love it. So, the challenge, I think, coming up, well, besides some of the obvious operational challenges like RF fields, we've probably every drone operator here, I'm guessing, who's flown around a site has probably had their control signal blown off by RF fields. And hopefully nothing between you and home when it decided to go home. And that's going to be a challenge for some cases of avoiding that. The other big challenge that faces the whole drone industry in general is going to be the data deluge. There's so much stuff coming off these drones, so much data, overpowering amounts of data that are going to be collected. There's a man, his name's Martin Woodall. He is the former business partner of Mark Cuban, helped him start his empire, I guess. He's a computer guy. Martin Woodall called me up once and wanted to use that 1,500-foot video as a flagship video on a company that he has, which is called Drone Data. And the only purpose of that company is to create a place to house data collected from drones, because it sees that coming. That all of this data, it's like me, personally, I'm getting so many hard drives on my desk, I don't know what to do with them all now because of the stuff I get. I don't know what to do. I have to figure out how to house this. And some people, like Martin Woodall, he's got the place to put it. There's a company here on the floor, Centera, that's all about collecting drone data and using it and manipulating it. And that's going to be a challenge to every drone operator and everybody who's interested in all of the imagery that we catch, whether we catch it through a device or a camera or a drone or whatever. The people in the know see this overpowering, I'm just calling it the data deluge. They just see this overpowering deluge of stuff that's going to have to find a place to be stored and used and manipulated, other than handing a thumb drive to the customer or something like that. It's going to get hard to do. And the context thing, in closing of my remarks, is what is it about that one video that made it go viral, where you have all the other climbers' videos that aren't necessarily that much watched? And the drone view, stepping off of the tower and looking back at it. We're used to seeing all the photos of, that we take, the tower and everything in our face. But you step away from it with the drone, puts you on the magic cloud, and you're standing away from the tower. And that view, right now, it's really cool to us. We love it. The question is it useful? What can you do with it other than it's really cool? That's what my boss always asks me. It's like, well, it's really cool, but what good is it? What can you do with it? And that's the question. One good example of maybe where that's going to go as this develops is that there was a customer who was complaining that a tenant on their tower had placed an antenna and caused it a nested situation with their beacon at the top. And there was arguing, oh no, we didn't. Oh yes, you did. Oh no, you didn't. Well, hey, let's send a drone up. So a drone is sent up, and sure enough, it's nested. So problem solved, figured out right there. But as the people in the know, or the people who knew how to interpret that photo and what they were looking at, looked at it, they said, oh, well, this antenna platform is not in the right spot. Oh, and check this out. There's a U-bolt missing off the safety climb top landing bracket, and 2 or 3 or 4 other things that were not intended to be found out, but that were found out solely because that picture existed. So there's maybe a little bit of a seed or an idea of where this all goes and how these images are going to open up a new way of looking at things that may actually have real value. And Dave, he knows a lot more about that than I do, so I'm done.
All right, tower climbers, one of the most dangerous jobs in the world, according to the Department of Labor. Safety first is our mantra at Hazon Solutions, and I know it is for every company, especially doing risky jobs. There's not a more valuable asset for any corporation, any company, any organization than the people. So all the processes, procedures, and technology, what can we utilize to make folks' jobs easier, safer, and provide more valuable information? Unmanned systems, without question, is revolutionizing the way that we're doing work, especially risky jobs. I mean, we're only at the very tip of the iceberg on the capability and what this platform is going to be able to provide and its sensors. Good morning again. I'm Dave Culler from Hazon Solutions. I'm the CEO of Hazon Solutions out of Virginia Beach, Virginia. We are a veteran-owned and veteran-operated company. We're very proud of that. This is our mission statement. We conduct, we support, and we develop unmanned systems operations. Our goal and our focus at Hazon Solutions is to provide the best quality, safety, and value to our customers. This is our mantra, safety first. Customer first and safety always. Here's our leadership team. Up in the front, I've got Sean Cushing as the president of the company. We are very Navy-centric. So go Navy, beat Army, but we do look for anyone in the military to join the Hazon team. We have Phil Larson down here in the front. He's our telecommunication guru, the smart guy in this space. He's currently the vice chair on the NWSA, and he's also co-chair on the integration for unmanned systems for NATE. So what makes us unique, what makes us different is our leadership and our background. This is what we did, myself and Sean, the president of the company, and a lot of the other leadership in Hazon Solutions. For Sean and I, over 50 years of leading large commands, landing on aircraft carriers, operating in combat zones. And to do that and do it effectively and do it smartly and safely, you have to have the right standards, you have to have the right safety program, you have to have the right training in place. And that's exactly what we bring to Hazon Solutions. That's woven into the fabric of what we do every single day. Our safety culture is something that's up and down the chain of command. There is no pecking order for safety. Everybody in the company is a safety officer. Our execution process, the way that we conduct our missions from the pre-mission preparation and planning before we actually go out to a site for the customers that we're working for, to our briefing, the way that we execute, and then really most importantly, what we do when we're done with the mission. How do we debrief it? How do we gather the lessons learned? We're always going to make mistakes. If you can't admit that you're making mistakes, then you're doing yourself injustice and your company injustice. So we know we're going to make mistakes. What do we do with those mistakes to get better? Customer mentality, customer first. If we're not doing what we should be doing to take care of our customers and exceeding their expectations, then we know we're not going to be in business very long. And the back-end deliverable, Todd talked about this. This is crucial. It's expected that we're going to go fly structures. We're going to capture the information, the data that you need. But it's what do we do with that information and how do we provide it back to our customers so that you can make rapid, smart, informed decisions. And for us, this is a little bit of a foot stomper, but we're doing it. We're working in the energy industry right now with several companies. We're working in transportation with some major railroad companies, and we're also in the telecommunications space. So we're going to talk about kind of how we've gotten here, but we're out doing it every day, gaining invaluable experience. This is kind of how we got started. Back in 2014, we put together a testing training program with Dominion Virginia Power. We're developing our safety, our standards, and our SOPs. We linked in with Virginia Tech and the Mid-Atlantic Aviation Partnership. They're one of 6 test sites in the country. Right now we have an MOU with them, and they are pretty much like a research arm for Hazon Solutions. So we're very excited about the partnership with Virginia Tech. They helped us get the approval for the testing with the FAA, and we started doing validation testing in our testing program. Then we went out and we wanted to get 333 exemptions. For those folks that don't know what that means, is that it's an exemption that the FAA allows you to go out and actually do commercial work. You can get paid to do the work. There are a lot of limitations which I'll talk about, but currently that's what allows companies like us right now to go out and provide this valuable tool to our customers. This is just a little bit more of the detail of how you build this capability. System requirements depending on what mission. I mean, what UAV are you going to fly? What sensors do you need to accomplish that mission? Making sure you do your publication development from your standard operating procedures, your training program, your safety program. Making sure you have the right training program from ground school to flights to training your instructors. And then understanding what all the FAA rules and regulations are. That's crucial and that's key. If we don't abide by the FAA regulations, then it's going to set this industry back, and we're not going to be able to go out and do the good work and save lives. Again, we got our FAA certificate of authorizations for testing. We did a testing program with Dominion Virginia Power. The great thing about this was it allowed us to validate our standard operating procedures, our training, and our safety. And then we now have 5 333 exemptions, one of which is infrastructure inspections with 4 others. And then proof of concept, we're out doing it. We're out proving that we can do this, we can do it safely, and we're gathering the information and data for the customers. And again, this is experience that we're gaining every single day. The research and development piece of this is moving very rapidly. It's going to continue to move very rapidly as technology continues to evolve. That's the full organic capability. There's a lot of companies that want to build a UAV company with inside the lifelines of their company. I can tell you to do it right, it's extremely complicated. So what do we do with these unmanned systems? How can they be a tool in the toolkit to make us provide more value to the customers and make our job safer? The first thing is precision inspections of critical infrastructure. And the precision piece is you can see these UAVs flying near a cell tower structure. It's pretty easy to go out and fly a UAV around the backyard and zip around your backyard and hey, this is not too hard. But you get up near critical infrastructure at 200 feet where it's gusty and windy and you're trying to put that UAV in the right vantage point so you can collect the right information and data. It takes the right training, it takes the right standards to do that and do it effectively every time. There's no excuse for running into critical infrastructure, so we have to do it right every single time. The other piece of the precision is the data that we collect. So getting that unmanned system in the right vantage point so that we can zoom in and we can get the information that we need. This right here, you can see the asset tag. As we zoom in, you can actually read the asset tag. For a climber that's up there, I think you're probably going to have to get 6 inches away to look at this asset tag and actually read it. It's pretty difficult. This is about 20 to 25 feet away with an unmanned system. I'm going to show you a video. This is some testing that we were doing, proof of concept on a cell tower. And as we go through this, you can see some of the vantage points that we're getting. Again, this is about 15 to 20 feet above the tower structure. That's invaluable information right there. And this is done with a 4K camera, so this screen up here is not doing it justice. You put it on a 4K TV, it's amazing what you can do and zoom in and see. We can see lock washers, and I've got some still images I'll show you here in a second. But just a situational awareness for a climber's going up to be able to look at this structure and understand what environment that he or she is getting into before they go up the structure, I think is invaluable. Pretty hard to get those kind of look-down angles. This next slide is some of the still imagery that we collected. So from the video, we took some still images, and it just shows, again, the clarity as we zoom in and what we're seeing. Again, this is about 20 to 25 feet away from the structure that we're able to read asset tags and labels. And again, this is a lot of the post-mission that we do to make sure that we're collecting the right information depending on what the inspection requirements are. Obviously, you can see that asset tag right there is a little bit buried, so that's one thing we can't do with the UAV yet, is put an arm out there and move that asset tag so we can actually see it. So as we are talking to our customers, the customers need to understand that's a requirement that we need to make sure as sites are being developed that things are put in place that will allow the unmanned system to see and collect the information that you want collected. Again, this is all a lot of post-mission that we go through as we're going through the checklist to look at the data that we've collected. All right, what else can you do in an unmanned system? How about for training? And this is what we did in the Navy. When we flew fighter jets around in the cockpit, we had video recorders that recorded every single thing you did. That was the most valuable thing for us to get better, was to come back and do a debrief and watch what we did right, and more importantly, what we did wrong so we could learn. So in this example right here, you've got several folks up on a structure that are training on the climbing. How about putting an unmanned system within 20, 30 feet away, recording the entire thing? So you brief the evolution, you go out and execute it for your training, and then you come back and sit in the classroom, and you're able to look at the video imagery and see what you did right, more importantly, what you did wrong. And then you start collecting that into lessons learned. And so the folks that were out there doing the training, they're learning, but everybody coming behind them is also going to learn because they can see some of the mistakes that are being made before they even get on a structure. How about pre-mission preparation? Before you even go up on a structure, to be able to go up and see, hey, do you have some icing up there on the top? Do you have a bee's nest? Is there a bird's nest? What kind of hazards up there? Have there been some new kind of things that have been put up there that are not on the engineering drawings? So again, enhancing your situational awareness before you ever go up the structure. Next few slides I'm going to talk about is some laser radar imagery that we've been doing. And we've been doing this to capture some 3D models. Again, to find out the validity of some of the measurements that we can get using laser radar, specifically for azimuth measurements for down tilt, and then for some of the rad centers on the antennas. Again, this is a job that obviously folks have to climb up the structures to get those measurements today. So what we did to validate our actual measurements is folks did go up the structure, not from our company, but from the tower company, obviously, take all these measurements so that we could compare and contrast what we were getting with the laser radar. So for the rad center, we were within 2 inches, so we were less than 2 inches of accuracy on all the measurements that we were making, which was pretty incredible from what the folks had gotten earlier that day. As far as the azimuth, again, very capable system with over 10 satellites for the accuracy. We were inside of a degree for all the azimuth measurements that were done earlier during the day. And then for the down tilt, less than 1 degree. We were meeting all those specifications on the down tilt for all these antennas on alpha, beta, and gamma. So some pretty exciting technology that's out there that's, again, going to hopefully alleviate some of those climbs and gather some of this information and again, improve the safety. One of the other things we did this past summer is we had the opportunity to work with Crown Castle on a project of determining throughout the day on a structure, what does the sun do to that structure as the structure heats throughout the day? Does the structure actually move? The temperature throughout the day started about 60 degrees in the morning, and then it got up to about 96 was the top. Very light variable winds, so winds were not really a factor. And we did 6 scans per hour throughout the entire day with the laser radar to determine how this, the movement of the structure. So the first one you can see here, if you look all the way over to the left, it looks like the target. That shows you, we'll talk about that here in a second, but that shows you basically where the structure is moving. It's being measured off the very top center of the plumb and how far it's moving out. So at 7:30 in the morning, temperature is about 71 degrees. It's already sitting off to the west about 8.2 inches from the center. And the center point is obviously that dotted line there. As you got to 8 o'clock, it moved another couple inches, so 11.5. And then by 8:30, as it starts heating up, it's already moved over to 17.4 inches off the center. So obviously that has an impact on your down tilt, what the azimuth is, and the rad center. This is a little bit later today, so later in the morning. The furthest that it went out there in the green is 9, and it went out to 18.2 inches. And then it actually started coming back towards the center as the sun started to get to high. And again, this is off to the west as the sun is rising to the east. This is about 1:30, between 2:30, so we're about 6 inches off. And then it pretty much straightened up all the way late in the afternoon. So this is 4:30. And then kind of surprisingly, it really didn't go too far off to the east. So as the sun's going over to the west side, the furthest that it actually went over was about 3.1 inches. So this just kind of shows you, again, a top-down view as to how that tower moved throughout the day. So some very valuable information. Again, this was a one-day test for 12 hours, so depending on the temperature and obviously the winds, you're going to have a lot of different impact on the structure. And this is just another 3D model. It kind of shows a top view. And again, you can see at 7:30, it was already over. It's kind of that gray line, about 8 inches, and then 11 it moves in the green, about 16, and then at 6:30 all the way back over to the east side, only about 3 inches on the other side. And this is just a 3D model that kind of movement. You can see it kind of repeats itself, but you can kind of see on the top view of how the structure is moving around. Okay, just a few things on the FAA rules and regulations talked about for small UAVs less than 55 pounds. You have to maintain visual line of sight. So for the individual that's flying the UAV, they have to keep the UAV within visual line of sight, daylight only, and good weather. The two different things that you see up here, you've got the 333 exemption, which again are you apply for through the FAA. They give you a 333 exemption if you pass all the wickets, and that allows you to actually go out and do commercial work with restrictions. The proposed rules by the FAA, which are going to be less restrictive, which we've had an opportunity to review and make comments on, is supposed to come out this summer, and that's going to allow us to do more work with unmanned systems. So just a few comparisons for your situational awareness is 333. Right now we have to have a visual observer. So we have somebody that's flying the UAV. We have a sensor operator that's a separate individual that's also a visual observer as well. So supporting the pilot flying the UAV. When the proposed rules come out, that's not going to be a requirement anymore. Even though we'll probably as a company continue to do that for the safety reasons. Maximum of 200 feet with a 333 exemption. If you want to go higher than 200 feet above ground level, you have to get permission from the FAA to go up to 400 feet. Right now we have a COA, and so it's a special permission from the FAA to go up to 600 feet for a customer that we're supporting that wants a structure that's about 550 feet up. When the proposed rules come out in the summer, it's going to be 500 feet. So see, there's still going to be some limitations that we'll have to get approval by from the FAA. And then right now you have to be a pilot, a rated pilot in the FAA to fly a UAV. For the summer, you'll be basically considered an operator, and you have to take a knowledge test from the FAA. So that's going to open it up, the aperture, a lot more for folks that want to do this mission. But for companies, I would say you need to be careful as to who you're looking at and who you're hiring. I think the goodness to it is you've got a lot of folks coming out of the military that are unmanned systems operators that may not be pilots that could do this job very effectively. So again, it goes back to your standards, your safety, and your training program. And this is one of the big ones right now for the 333 exemption. So if we're going to look at a tower, there's a 500-foot bubble that sits around the unmanned system, or the UAV. So as it's moving around, that 500-foot bubble is basically centered, the UAV is centered in that 500-foot bubble. So if we're going to go look at a structure that's near a freeway, we cannot legally do that because you cannot fly over any non-participants that are in a vehicle, a vessel, or a structure, or standing outside, unless you get permission from them. So in order for us to do a cell tower next to a freeway that's inside that 500-foot bubble, we'd have to stop traffic or get permission from everybody driving their car. Some neighborhoods that we go over, we can go and talk to the folks in the homes, and we've talked about, and we've done that to make sure that we keep it legal. But again, for the proposed rules, you just may not operate over any person that's not involved. Something else that we're doing, again, with a partnership with Virginia Tech and the Mid-Atlantic Aviation Partnership is beyond visual line of sight. So again, as I discussed before, currently we have to maintain visual line of sight of the UAV. Where the future is going, where the technology is going to take it, and where it's already getting to, and once the FAA approves it, is that you will have systems that will be out flying beyond visual line of sight. And so they won't have an operator that has to keep visual on them. So right now we've got a three-phased approach. We're finalizing the ConOps with the Virginia Tech and the MAP, but we're also working with a major energy company that's very interested in this. We're gaining FAA approval, and we're looking at all the different systems requirements for doing the beyond visual line of sight testing. Phase 2 will be a crawl and walk phase. So we will have visual observers as like a daisy chain that will be probably every quarter mile down. And what we're looking at is on a transmission line. And that will go out to 5 to 10 nautical miles. And then we're looking at some repeater technology to make sure that we can maintain control of the vehicle, the UAV, throughout the testing. Again, this will be short ranges, probably 5 to 10 nautical miles, and then return. And then phase 2, we're looking at some sense and avoid technology that's out there with the FAA approval, and then some high definition first person field of view that gives you quite good depth perception as you're flying and going and utilizing multiple sensors, excuse me. And again, increasing those ranges beyond 10 nautical miles. We did have an opportunity with Dominion Virginia Power to do some, what they wanted to do is a storm assessment. So they wanted to see, hey, take a UAV up. We had to get approval to go up to 400 feet AGL, which we did from the FAA, and then fly down the line a little bit and then see how far you could see down the line to look at some of the structures and for any kind of storm damage. So we were able to see about 3 to 4, some places about 5 nautical miles, which we'll show a video here in a minute. But it was also an opportunity for us to kind of look at the profile for the future of a phase 1 beyond visual line of sight testing as well. So again, this is in Virginia. Again, this is 400 feet AGL, and you'll see we're going to be flying down this line. Again, we go out about 1/3 of a mile, and then we're going to zoom down the line. And you can see the structures and some of the capability that's out there right now to make an assessment for post-storm. And as we actually turn the camera here, you'll see down here that little lake, and as we zoom down there, that's about 3 to 4 nautical miles. And again, you can see the structures if they were to fall over, or if there was a tree on them, that you'd be able to make a pretty good assessment. We're also looking at some live feed technology as well that will allow you to see it real time. All right, so why unmanned systems? We want to reduce risk to personnel, again, our most precious asset. We should be improving situational awareness before you ever go up any structure. We want to reduce the number of climbs to mitigate risk, and then again, these unique vantage points that you can get with this really high definition imagery and a lot of other sensors that are out there and available. The bottom line is we want to enhance knowledge, improve the knowledge, so customers can make really smart, informed decisions. This is on a structure on one of the energy companies that we've been working with, and we've been working with several different energy companies. This is a cotter key that's backing out. We found several of these with different companies. This is actually a very big deal. They had crews out there within an hour up there repairing this, because if the cotter key backs out, the insulator is going to fall, and it could be a possible power outage and could be risk. So again, it's improving the reliability of the system and creating safety for those that are working in and around the structures. That's my presentation. Thank you very much, and available for any questions. Yes, sir.
You talked about FAA rules. What about industry rules? For example, do you have to shut down a complete cell tower to do an inspection?
I think that depends on the company. The ones that we've been doing proof of concept testing with, they have not been shutting down the cell towers. And we've got a lot of time on energy lines, on transmission lines, and we've seen a little bit of issues with some of the video feeds that we're getting, which is 2.4 gigahertz, but with controlling the UAV at 5.8, we haven't seen any issues with the unmanned systems.
Follow up.
Yes, sir.
What happens if you fly in front of a parabolic dish
that's still live?
I don't know the answer to that because we haven't done it yet.
Well, I got a good idea, but you know, that's something that it may come up in discussions because.
Yeah, and as I discussed in the briefing, you know, that's all part of the pre-mission preparation. So when we're going to do something that we haven't done it before, it's a part of understanding, you know, the frequencies and what the potential issues could be and how we would mitigate those risks. Todd, did you have something on that?
I've actually flown in front of a microwave dish fairly closely with no effect. I mean, I don't understand all of the frequency issues. I have lost signal in front of cell panels and TV sticks, and sometimes FM, sometimes not. I've also just lost, let's see, my control signal I think is 2.4 gigs. My video signal is 5.8. I've lost video signal and not control signal also, but I haven't had a problem in front of the dish yet.
Yeah, but are you interrupting that service?
Am I interrupting the service? I have no idea. Nobody complained, I guess. I can answer that question.
Question for both of you guys. Two questions actually. Have you entertained, or could you maybe elaborate on the concept of long-term tethered flight by microfilaments? Maybe explain that. I've heard a little bit about that lately. And then the other thing, are we going to work with drone manufacturers for better shielding as we move forward in the drone committee with Nate? We know that we're going to be flying in close proximity of high power television and FM stations. And do we want to consider working with the manufacturers to better shield batteries from heat and shield the computer systems from RF exposure?
Yeah, answer to your first question on the tether, it's something that we're not currently doing at Hazon Solutions. Again, we're moving out on the beyond visual line of sight, and I think with some of the sense and avoid technology that's out there, I think that's where we want to go. To your second question on the shielding piece, absolutely, and that's kind of one of the good things with us working with Virginia Tech and the MAP, and again, them being a research arm for us. We're going to be doing some EMI testing, so they're going to be able to put some things on our unmanned systems, so we'll be able to measure the EMI we're out doing transmission lines. So in line with what you're talking about for the telecommunications space, absolutely, and we could utilize, you know, the technology and the expertise at the MAP to, you know, get together and figure out what we want to test and how we want to test it. Because again, it's about understanding the information of what you're doing.
Thank you.
Sir. No more questions? Okay, thank you very much.